This video is on the objective calculate the mean and standard deviation of the sampling distribution of sample proportions. And this is number 2, right? So the second video on a question related to this objective from your Newton Alta homework. So I'm going to go, into a little less detail than I did in the first video. If you want a little more detail on the central limit theorem for proportions and all that, go back to that first video, number 1. I'm just going to show you some formulas here and plug in and we'll figure things out. All right. So here, in a recent survey of 100 new vegetarians, 74 said that their new plant-based diets were helping them feel healthier. So it's asking us to find the standard error or the standard deviation for the sample proportion of vegetarians who feel healthier, and round to 3 decimal places. All right. So again here, I'll identify some things now. A success in this particular problem. Right, a success in this particular problem was feeling healthier. And let me get rid of the calculator. I'll keep it up. I'll keep the calculator up. I'm going to be using it in a second anyway. All right, a success was feeling healthier. Now our sample, the sample size, right? They said they took 100 new vegetarians. So sample size n is 100. And again, x will represent the number of successes. Of those 100 new vegetarians, 74 said they were helping, this new diet was helping them to feel healthier. So I have 74 successes. Okay, so the sample proportion, p hat or p prime, you might see a p with an apostrophe, same thing. So again, it's the number of successes in the sample divided by the sample size. What proportion, what percentage of the sample is a success, feels healthier. So it'd be 74 divided by 100, and this is very simply just 0.74. Okay. Now, recall from the first video on this objective, I talked about the central limit theorem for proportions. Imagine you could take all possible samples of 100 vegetarians and ask them the same thing, and look at the proportion that say they feel healthier. Do it for all possible samples of size 100. And by the central limit theorem for proportions, the distribution of all those sample proportions, if I looked at every single sample proportion for samples of size 100, all those sample proportions would have a normal distribution, with a mean of mu sub p hat and a standard deviation of sigma p hat, or called the standard error of the p hats, where the mean of these p hats would just be the population proportion, p. But this is unknown. Right? We don't know what the proportion of the entire population of vegetarians feels healthier. We only know a sample. So we're going to start approximating this, right? So this is approximately our p hat here, our 0.74. And I'm going to use this as a point estimate, right, of p. Our first initial guess as to what the population proportion is. And the standard deviation, remember, for the sample the sample proportions, the sigma p hat, was the square root of p times 1 minus p divided by the sample size n. But again, I don't know p. I don't know the population proportion. So again, we use 0.74 for p as an estimate, and we estimate this standard deviation for the p hats as the square root of 0.74 times 1 minus 0.74, so 0.26, and all that divided by 100. Right, and I'll enter the, and this is what we're asked for. Right, this is the standard error, standard deviation for our sample proportions, same meaning, right? Same word, different words meaning the same thing. So I'm going to enter this into my calculator. So I got that pulled up. We got the square root of 0.74 times 0.26 divided by 100, and make sure all of that is inside the square root, and round it to 3 decimal places. This would be 0.044 approximately. And that's what we're asked for. Right? The standard deviation of the sample proportions for all possible samples of size 100. Or the standard error of the sample proportions. And that's it. Again, pretty simple calculation, something that probably looks familiar to you from when we talked about the central limit theorem for proportions in an earlier section. Set to 3 decimal places, this standard deviation, this standard error is 0.044. And I'll submit. And again, please read your answer explanations, whether you're right or wrong. Notice they're using P prime. I said, you can see the P with the apostrophe. P prime instead of P hat. They mean the same thing. They're both sample proportions. And they go through the same calculation I just showed you. Alright, and that's it for this kind of problem. Related to this objective. Hopefully watching this video helps when you're working on this kind of problem on your own. And thanks for watching.